I mean, just being gone for so long. Yesterday, I felt really offended that it wasn't Friday.
My sister, brother-in-law, and my brother are all teachers at my school. At least like the schools daycare.
Oh, really? Nice. I took it and I failed.
But there's a bunch of students in there and every classes, there's not like a daycare person. So it's almost like the teachers who their kids should be kind of advantaged the most for their life experience are advantaged the least because they can't help them during the day like other people could. So it kind of sucks.
Yeah, it was, I mean, thinking of a way that I could get this done was really tough.
Oh, I can't imagine.
You know, my mom is retired. She was a teacher. So that would be helpful, right?
Yeah.
She could help them, especially like I've got a second grader and that was like her grade.
First day he was like,
But
sure you know
super compromised health-wise.
Oh.
You know, so I was like, and I was like, so the kids are gonna be at school.
Yeah.
Around who knows who you're and I didn't feel comfortable with it. And I know like most people like, I don't know how scared I should be about this.
At all.
But I just feel like if something happened,
yeah, absolutely.
then I would just like never be able to live with it.
Yeah. I feel like for those people who are compromised, and it is more of a serious threat.
Yeah.
Like for average people.
Yeah, I
It's
don't.
something that we'll go through. I think everyone's going to
Definitely at some point.
Yeah.
Saturate the community.
And I think the odd thing is, I mean, not only pediatricians, I mean,
it's
very number driven people, you know. She has no worries whatsoever in the children. And so, like,
oh, really? Like,
see pictures in auditoriums having lunch 6 feet apart, no communication. It's so much a part of their learning experience is interaction. And there's a negligible percentage. I mean, there's a greater percentage of them dying in a car accident on the way to school than there is of them dying of COVID. We don't stop driving.
Right.
It's insane. I think that protecting those sensitive classes are very important.
that. I was like,
Yeah, kids. I mean, my youngest is, this is his first year of school. He started pre-K, and I can't even imagine. I mean, we've been having him at school since he turned 4, you know, and now it's like, well, you get to go a little bit, and it's gonna be weird. You're gonna wear a mask, and
It's just crazy.
I just feel bad.
she was like, why don't you contact Josh to help you? I'm like,
All right, so it looks like most of us are here. So before we get started, for you in-person people, I want to make sure you know that on Monday, we won't be here in class. We'll be all Zooming. If you don't have arrangement, like if you don't have like a device or something, like if you can't figure out a way to join in the Zoom meeting without being here in class, definitely let me know at the end of class so I can have somebody come into this room and turn everything on so you can see the meeting. If not, just, you know, stay home or wherever you want to be and join in the Zoom meeting. That's the easiest, at least, way to do it. Also, I've got a question for everybody. So as we start doing that Monday, Wednesday remote class, would you guys prefer or have any preference one way or another? So let's say at some point I want to try recording, like pre-recording my lecture for the day and then just posting it up
Mhm.
and you can watch it whenever you want? Or do you guys prefer having it at this certain time? And it's recorded anyway, but you know, having it at the certain time, you know, making you be here at 10 or be on the Zoom meeting at 10 every time. Do you guys have any pros and cons with that?
I guess the con would be if you have a question.
Right, if you have a question, you're not gonna be able to ask me.
But I think like if you were to do like a PowerPoint presentation of all of the stuff and it showed the progression of how you got to the problems, I think it would be a lot easier to reverse engineer how you did it, because you know, as you're writing it down, all of a sudden steps start overlapping as markings. So if it's going like step 1, step 2, step 3 until final, I think that part would make it easier.
Yeah,
for me personally.
so what it would be like me working out the problem. It'd be just like here, because I have a board at home.
Oh, okay.
So basically, I'd be talking and working problems just like I would here.
Mhm.
And whether it's in a Zoom meeting or it's pre-recorded, it would be that way.
Oh, okay.
You know, one pro to having a video is that you can pause, not rewind, what do they call it now? It's rewind? Yeah, rewind, fast forward, whatever you want. That's always nice, but you can always do that with the Zoom meetings anyway, because I record those. I think that at some point, I might just try one way or another and see how it goes. Sometimes if I found that in the spring at least, sometimes if I pre-record a lecture, if I get through some stuff and then I forgot something, like I can make it perfect if that's makes sense. You know, I can make sure I say everything I want to say. Because sometimes after class we get done and I'm like, I didn't even bring that up, you know. That was kind of nice for me when I did it before. Another thing that's nice is I could do it anytime that I had, you know, and then I could post it up at the certain time, or honestly, post it up at any time, you know. But definitely the big con is not being able to ask questions in real time. So that's a big one. Any other cons you can think of that? I mean, I know it's kind of personal preference. Do you guys care if we always, you know, like, is a schedule important? You know, like it's 10 o'clock, I want to get on and I want to have class, you know, or, you know, is that going to be something that hinders your sense of responsibility for the class, if that makes sense? You know, because when you're here every day at 10, you're here. That's one thing. But if I post a video and I'm like, hey, this is for Monday, watch this, you know, is that going to be a problem with like time management? Or, well, I can, you know, and you don't end up getting it watched or notes taken on it, you know?
I think it's good.
For me personally.
That's true, and I will have office hours available, and that's another thing I did in this spring was I pre-recorded, so the class times weren't taken up by a lecture. So I got on to my office hours, or I made office hours during class time. Oh, that's true, I could do that. I wonder how I would do that. Discussion board. Anybody know?
You just start a thread, and then people can just post that at any time.
Okay.
And, my other class did that was online.
To the
Okay.
communication chat, right?
Is it like a D2L thing?
Yeah.
Okay.
So like it was on Blackboard, but I saw that there's discussion board forums on D2L, so you should be
So
fine.
that would be a good idea. You know, that'd be something to think about. Yeah, see, it would open up you having more time to ask me questions during the office hours.
Yeah.
Because my office hours, I think they're from 1 to 2 every day. Everybody can't always be, you know, hopping on at that time. So that would give another time.
But if it's recorded, I mean, a discussion thread is recorded, so normally you can go in there and access the discussion thread.
So like if you had a question, you could go see if somebody's already asked it.
Because it's meant for people like, oh, here's the question, and kids will come in and answer at their own time.
Okay.
So.
I like that. So things to think about. Now I will say that on Monday, it'll be the Zoom meeting at 10.
Yeah.
So for our first one, we'll see how that goes. like I said, I have a board, so I'll get on the meeting, I'll do my lecture like I would do here. My board's not as big, but it's a pretty nice size. I just have to erase more often. But we'll make sure everybody has good visuals on that too. We'll, Monday will be getting used to everything like that. But in-person people, at the end of class, don't let me forget, and I know you probably have it in an email somewhere, but I'm gonna write my Zoom info up here so you can write it down or take a picture or something at the end of class, just to make sure you do have it for Monday.
Okay.
So Monday we'll do just like this at 10. And then from there, I'll maybe look into like discussion boards, different resources, and we'll talk about how to go from there. Okay, so let's get started though. That's pretty good. All right. So last time we did get away from the graphing and we were looking at finding limits algebraically. And what we found was that if your function is what we call polynomial, which means it doesn't have any undefined values, it's smooth, it does what it says it's going to do or what you think it's going to do. If we have these polynomial functions, I could take the limit of one of these functions simply by putting in the x value that I was approaching, because I knew it was actually going to reach that value. So as an example of that, just to recall, if I want to take the limit as x approaches 3 of the function 2x squared minus 4x plus 5, could I just plug in 3? Because this is a polynomial function, right? And how can I tell? Well, any exponents that are on my variables are positive and they're whole. So I don't see any roots here. No denominators that could give us issue. So no issues whatsoever. I can plug in 3. Just as a notation, as you're doing your work, once you plug in the number, that is the act of taking the limit, so you don't have to write limit anymore. Once you actually do the act of taking the limit, you drop that. And then we just write our answer. So plug in 3 for everything here. We get 2 times 9 minus 12 plus 5. So 18 minus 12 is 6 plus 5 is 11. And we get our limit there, which is the same as if I put 3 into the function and found like f of 3. Okay, so that's straightforward. And then we did one that did have a denominator, and it was not a polynomial function, but we did a workaround, right? So if you do have a ratio, so something on top, something on the bottom, like x minus, oh wait, I want the 2 on the bottom. That would be weird. Okay, so how about x minus 5 over x minus 2? So we talked about this and we said, okay, because it's not a polynomial function, I can't just stick in that value. I might be able to, but I can't assume that I can. So I had to go to those properties. And the property for this said that I could take the limit of the top and the bottom separately and then just leave them as a fraction. So I could try that. If I do that and I put a 2 minus 5 in the top and a 2 minus 2 in the bottom, so acting as separate problems, we saw that this is polynomial on its own. So I just put a 2 in there. This is also polynomial on its own. So you put the 2 in there. And then I get this negative 3 over 0. So that's a problem. And remember when I talked about that property with the quotient, with the ratio, it only works as long as your answer down here for your limit doesn't end up being a 0. What can I say about this?
Undefined.
I just say it's undefined. You guys, now, this problem might actually have a limit. Maybe on this graph, this is just a hole. And it's actually approaching something on both sides. But you guys, algebraically, I don't have a way of knowing that. So unless I graphed this like on a graphing calculator or just sketch graphed it, I wouldn't really know what's going on here. It might be an asymptote. Maybe both sides are going to negative or positive infinity, but that's not something that I know algebraically just by looking at the problem. So we say it's undefined and that's fine, and we move on because that's all we can do. What about this one? I want to take the limit as x approaches 4 of x squared minus 16 over x minus 4. So just by looking at it and seeing the number that I want to put in, it looks like a problem, right? Well, sometimes I can work around that. I can work around the problem, and I can't always. Now this one definitely is very straightforward. There's no way I could rewrite this problem to not have x minus 2 on the bottom. But if my problem's a little more complex, think about trying to factor something out maybe. Is there a way I can rewrite this problem to possibly get that x minus 4 off of the bottom? There is. So guys, x minus 4 is just x minus 4. I can't do anything with that, but what can I do on the top? Right, so this is the difference of squares, right? So there, I have a factoring method for the difference of squares. We are going to use it, so I'll recall. You guys, if you have a term like this, a binomial term, that's a perfect square minus another perfect square. And it does have to be minus. And that's what I have here. X squared is always a perfect square because you root it and you just get x. 16 is also a perfect square. So if you have this, it always factors in. Wow, that is a thing that is there. It always factors into the same template. You're always going to get one factor, a plus b, and then the other factor is always going to be a minus b. You get what we call a conjugate pair, which is the same a and b, just one with a minus, one with a plus. So let's use this to factor what we have here. So make sure you know that we're starting with the squares, but this a and b are the roots of those squares. So I haven't taken the limit of this problem yet. I'm just rewriting the problem, so I still have to keep my limit. But I'm going to rewrite x squared minus 16 as what?
X plus 4 and x minus 4.
So just using this here, I get x plus 4x minus 4. And on the bottom, I still just have that x minus 4. What can I do now?
Cancel out.
I can cancel out. I found that I really have x minus 4 on the top and the bottom. So you can absolutely cancel those two out. I haven't taken the limit yet, so I'm keeping my limit in there. But now I can rewrite this problem as just what's left, right? It's not even a fraction anymore. It's just x plus 4. Can I stick 4 into a function like this? Absolutely. There's no fractions, there's no roots, it's polynomial. So now I am going to take the limit by sticking a 4 in there. And I find my answer. So I actually got an answer on this one, even though it didn't look like I could. Can we rewrite all of these types of problems? Definitely not. But if you do have something up here that looks like it might be able to be factored, like if you have a squared or something even higher, but we'll probably stick with squared, try to factor at least. Could we have tried on this one? No, it's just an x minus 5 by itself. There's no factoring going on there, but we could do it on this one. So if you can rewrite, try to rewrite. You'll see on your homework that you have ones that you can rewrite. You guys, is the difference of squares the only type of function you can factor? It's probably one of the easier types to factor, but you might see some. Let's do one more of these because we need to review our factoring. Let me think of a problem first. What if I had x squared plus 4x plus 3. That seems like an easy factor. And on the bottom, I have x plus 1. And I want x to approach -1. Okay, let's do this one. So first of all, I can't just stick in -1 now, right? Yeah, because the bottom would be 0, but I'm like, hey, possibly could I rewrite this? Maybe I can get around that denominator. So this definitely isn't the difference of 2 squares, but it is a quadratic term, right? Anytime you have the squared and then the first power and then the constant, we're looking at a quadratic trinomial. How do I factor these usually? So they're going to factor into 2 binomials, just like this one did. But we use, there's a lot of different methods. Some people, we call it like reverse FOIL. So if you started with the 2 binomials and you FOILed them out, you would get to here. So I want to go backwards. There's a lot of different factoring methods. I'm going to show you the one I use. And you use whatever you want, because you should have to this, at this point factored at some point. So let's take that x squared plus 4x plus 3 to the side. I want it to look like this. I want it to look like 2 binomials. Now, the first term comes from this first term. So I look at whatever this is in my problem, and I try to find 2 factors that multiply to that. You guys, it's really simple if your first term is just x squared. There's only one way to go about it. It's got to be x times x. So I took factors of the first term, x times x. The 2 last terms actually come from factors of this last term. But sometimes there's multiple choices. So with 3, there's really one choice, right? You can only factor 3 with a 3 and a 1. But what if this had been a 4? You guys, would I do 2 and 2? Would I do 3 and, no, 4 and 1? I'm adding now. You know, like, or 6. Do I do 2 and 3? Do I do 6 and 1? There's a lot of different choices sometimes. On this one, yes, it's easy, but I'm still going to show you how to make the choice. So you pick 2 factors of that last term. Let's say I pick 3 and 1. I add those 2 factors together. They have to equal this number here in the value and the sign of the number. So if these positive 3 and positive 1, do those add together to make a positive 4? Absolutely. That's how you know you have the correct factors. Again, on this one, there wasn't really a choice, but you can always check. So positive 3, positive 1, and now you factored. So let's rewrite our problem. So I haven't taken the limit yet. So I want the limit as x approaches -1 of x plus 3 times x plus 1 over x plus 1. Now it looks a lot like this did, and you find a cancellation. So we cancel our x plus 1s, and all this really says is that I want to take the limit as x approaches -1 of x plus 3. And then from there it's easy, right? Let's put the -1 in. We get -1 plus 3, and we get our answer. We get that the limit is 2. So always try to rewrite. Sometimes you really can't, and your answer will really be undefined. But sometimes you can. You don't want to miss the ones where you can, and call it undefined when it's not. Okay, what about the other problem? Remember when I said a polynomial function doesn't have any denominators, but it also doesn't have any fraction powers, which are roots, right? What happens if I have a root? Some roots aren't a problem, but some roots are. So I've got something like this. You guys, this is not polynomial. There are going to be definite problems, right? Under a square root, positive numbers are fine, right? Anytime. Is 0 fine? You take the square root of 0, it's just 0. That's cool. But what happens when you get a negative number under here? That's the problem, right? It's undefined. So there's a whole section of this graph that just doesn't exist because values of x would make what's under here negative. So when you're doing a root, you just really need to pay attention to the value you want to put in. So I want to do this one as x approaches 2. A lot of times we can just plug it in. The only thing you have to be careful with on a root, like I said, is just make sure that it exists. So do you think it would be fine if I put a 2 in here? So if I put a 2 here, 4 times 2 is 8 plus 2, I'm going to get a 10 in there. Can I have the square root of 10? Yeah, that's okay. So I think because I checked beforehand, I'm just going to plug it in. I'm going to pretend it's a polynomial function. So what do I get here? I get the 4 times 2 plus 2, and I get the square root of 10. And that's that. That's the limit as x approaches 2 of this particular problem. Cool. What if I put in the limit as x approaches -5 of this same 4x plus 2? What happens when I plug that in? I get a negative, right? So guys, before I even try it, that's going to be -20 there, plus 2. It's going to be -18. Is it going to work? No, I can't just plug this one in. Now this one is going to be undefined. You could, I guess technically you could plug it in and see that it's undefined. At a point you want to just be able to tell. But there is, the roots, there's no rewrite, you know, like that one. There's no rewrite here. If it's undefined, it's undefined. Every square root graph has a starting point and it goes a certain direction, and then there's a whole portion of the graph that just has undefined values. It's just the way it is. What about this though? What if I change the problem just a little bit? Do you think this will be a problem? Why are cubed roots better than square roots? Well, because I can actually take the cubed root of a negative number. It's only the even roots that give us trouble. So the square root, the 4th root, we don't usually take that, but the 4th root and on, any even root has problems when you put a negative under there. That's where it gets undefined. But a cubed root question, this exists everywhere. So if you see a cubed root in a problem, just plug it in. Your answer is going to be your answer. If you see I don't know why you would, but if you see a 5th root, that would be okay. Any odd root is fair game. Okay. So you guys, I think with this stuff being said, that gets you through your 11.2 in the homework entirely. You can do all of that as you look at it. So let's move on just a little bit. Basically, what I want you to get from 11.2 is plug it in. If it doesn't work, that means it really doesn't work. We have a lot of the properties and special rules, and yes, we're using them in the background, but for the most part, you really are just plugging in values. And they're either working or they're not working. The only one with a little bit of complication is the ones with the quotients where you'll have to factor and possibly rewrite. Okay, so now that we know how to take limits, we can move on to bigger and better things. I say move on, and I'm about to show you something that's review, but I promise it will get more complicated than when we first learned it. I want to talk about rate of change. So rate of change is definitely an algebra problem, but I'm going to review it for you. I'm going to show you what it means. So I'm going to draw a random function, like always. Let me do like a parabola. Got a parabola. And I want to know more about this function. So this class, again, I'm not just going to ask you to find f of 2 or f of 5 or f of 3. I don't care about the static points. I want to know how this function is changing. So the first way we talk about change in a function, before we learn better ways at least, is to talk about the rate of change of a function. So what rate of change does is we pick two values of x. We usually call them a and b. I find the function value at a, and I find the function value at b. And I want to know how they're changing, not just by subtraction or something like that, you guys. What I actually find is the slope between these 2 points. So from a to b, how is this graph, how much is it increasing? At what rate is it increasing is a good way to say it. Or what rate is it changing? So this is what I'm looking for. Now, look at the margin of error here. This is my actual graph. This is actually how it's changing. The calculation I'm about to do is off, right? What it's doing is it is averaging that change. When you connect 2 points with a straight line, in other words, we are linearizing this function between these 2 points, we're getting an average rate. Because here, you know, it's increasing, but maybe not that fast. And then it gets faster and faster and faster. So the rate of increase is actually changing from A to B. But my line has one rate of increase. It's called the slope. And it's constant throughout. So it's an average change. So to find this average rate of change, which no, it's not a great measure. It has a lot of error, but we have to go through this to get to a better way. If I want you to find the average rate of change, we are absolutely just taking the slope between these 2 points, pretending that these 2 points are connected with a line and finding the slope of it. So let's think about how to find that, and we're going to use function notation. So if this is A and B, what would the associated output be here if I labeled it in function notation?
Be 0.
So I mean like this y value here.
Mhm.
What if I called it f of a? So I put in a, what do I get out in my function? I get f of a. I get the output when I put in a. That's a general way of saying it, since it could be anything. And if this is b, so its output, its y value is up here. I'm going to call that f of b. So input, output. These are x values, these are y values, but function notation, we use f instead. How do I calculate a slope, any slope of any line?
What was the next plus B?
So that gives me this, the equation of the line, n is the slope, right? So how to find actual slope? I take the difference in y's on top and the difference in x on the bottom. Basically, output change over input change. So that's going to be my formula for this average rate of change, which again is really just the slope between 2 points on the function. The average rate of change on top is going to be the difference in the outputs. We'll start with the larger one. So f of b minus f of a. And on the bottom, it's the difference in x values. So b minus a. So even though this has a's and b's and function notation, there is no difference here between your normal slope. What is it? y2 minus y1 over x2 minus x1. It's what we're doing here. We can't call it that. We can't actually say what's the slope of this because this function is not a line. Oh, hey, this function is x squared. What's the slope? That doesn't make sense. But I'm just averaging. I am finding this slope. So let's look at an example. Actual function. So let's say f of x equals 2x squared plus 3x minus 5. And And what I want you to find is the average rate of change between x equals 1 and x equals 4. So this is how your problems are going to be worded. What do I need for an average rate of change? I need 2 inputs and I need 2 outputs. Which one of those have I given you? I've given you x values, right? I told you what I want the inputs to be. What I didn't tell you was what the outputs are. Could I find them? Absolutely. I've got a function here. So you guys, your 2 x values, let's call this a and b if you want. I need to find f of a and f of b. So if x is 1, I need to find the output at 1. I need to find f of 1. So let's find it. Put a 1 in for these x's. So I get 2 plus 3 minus 5, so 0. So I get a 0 for that output. Let's find the output when I put in a 4. Sorry, it's getting close. Everybody can see that. No, they can't, can they? Hold on. I wrote in a place you couldn't see. I'm going to fix it up. I know I don't have to yell. Okay, there we go. So guys, I'm putting 4 in to the function. So remember 4 squared first. So this is 16 times 2. We get 32 plus 12 minus 5. So 39. Okay, so what I've done here is I've found 2 points on my function, right? I found a point at 1, 0, and I found a point at 4, 39. What am I going to do with these 2 points? I'm going to calculate the slope between them. I'm going to use my formula, but again, all the F's and A's and B's here, don't let that throw you off. It's just in function notation. This is just calculating the slope between these 2 points. I gave you half the point, you find the other half, and then you do the slope. So my slope, or my average rate of change between these 2 points, so the outputs go on top. So let's do y minus y. So I get 39 minus 0 over x minus x, or b minus a, 4 minus 1. Make sure when you're doing this, you go in the same order on top and bottom. So if you do b minus a, you better do f of b minus f of a. If you did a minus b, then you would do the same on the top. But anyway, we're here. And we get 39 over 3. And we get an answer. We get 13. These usually turn out to be whole numbers. Now, what is this saying? Well, it's saying that pretend this is the function. From this point to this point, if you were to draw a straight line between those 2 points on the function, your slope of that line would be 13. It's increasing at that rate on average between those 2 points. So again, definitely a lot of margin of error here. There is more going on than we're able to calculate with that rate of change, but it's something, right? It's a measure of change we can calculate, and next time on Monday, we will be getting closer. We'll try to close that error. Okay. All right, guys, so that's it for today. I'm gonna put up for my in-person students, before you leave, I'm gonna put your Zoom info on the board just to make sure you have it for Monday. It will be at 10. It will be just hop onto the Zoom meeting. We'll have our normal class. Okay, there it is. And to people, you already know that.
There's not a link on there, it's just log into Zoom.
So if you don't have a Zoom account even, it doesn't matter. If you just go to Zoom and click join a meeting, you can join this. I mean, it's probably good to have an account because we're gonna be on it a lot. But either way,